Capacitors are devices used to store electric charge consisting of one or more pairs of conductors separated by an insulator. We can find them in most circuits. You usually find them in high quantity depending on the circuit you are looking at. Capacitors are vital components in all types of electronic equipment. They can be found in computers, radios, cell phones, television, appliances as the refrigerator, and Wi-Fi routers. Capacitors come in different sizes and shapes. They can be big or small. They can also be fat or thin. They can come in cylindrical shape or in rectangular ones. These are the symbols for capacitors: polarized and non-polarized.
Okay, for the series circuit, you will use the formula written on the board. Then you substitute with the given values, then you simplify. For our answer, we will use a 3-digit decimal number. Now for capacitors in a parallel circuit, we will simply add their capacitance values. In our case, the answer will be 3 farads. First problem. Number 1. A parallel plate capacitor has an area A equal to 2 times 10 to the negative 4 meters squared and a plate separation D equal to 1 times 10 to the negative 3 meter. A. Find its capacitance. B. How much charge is on the positive plate if the capacitor is connected to a 3-volt battery? C. Calculate the charge density on the positive plate, assuming the density is uniform. And D. The magnitude of the electric field between the plates. Now, the solution. For A, we will use the formula C is equal to epsilon naught A over D. Then we will substitute with the following values. And thus we will have the answer 1.77 times 10 to the negative 12 farad. For B, we will use the formula Q is equal to C delta V. We will substitute with the given values. And we will have the answer 5.31 times 10 to the negative 12 coulomb. For C, the charge density can be calculated using Q over A. We will substitute with the given values. we will have the answer 2.66 times 10 to the negative 8 coulomb per meter squared. For D, we will use the formula E is equal to delta V over D. We will substitute with the following values. And we will have the answer 300 volts per meter.
In testing capacitors, we need to make sure that when the positive and negative probes are connected, the resulting voltage will be zero. This is an important step to obtain accurate results. There are 5 different conditions for capacitors. They are good, open, short, leaked, and can't be determined. In a good capacitor, the resulting voltage is between 0 and infinity, and it deflects. In an open capacitor, the resulting voltage is at infinity. In a short capacitor, the resulting voltage is 0. In a leaked capacitor, the resulting voltage is between 0 and infinity, but it does not deflect. In a can't be determined capacitor, the results will show 2 different conditions.
Capacitor technology is expanding beyond the printed circuit board as demand grows for a new generation of supercapacitors that are capable of performing energy storage applications, supplementing or even replacing batteries in applications including data storage, wearable devices, electric cars, and even aircrafts. UCLA's California Nanosystems Institute announced it has developed a hybrid supercapacitor that exhibits features of both batteries and supercapacitors. The new hybrid supercapacitor stores large amounts of energy, recharges quickly, and can last for more than 10,000 recharge cycles. While many of these technologies are in the early stages of development, supercapacitors could be destined to play an increasing role in energy storage, supplementing, augmenting, or even replacing batteries in a range of new applications.